Kia ora everyone, welcome to a video on linear patterns and tables. Okay, so what exactly is a pattern? A pattern is basically a repeated sequence. What is a sequence, I hear you ask? A sequence is a specific order of something happening. So it could, in the case of numbers, we can have a number sequence. For example, 1, 2, 3. And in a pattern, the sequence is repeated. So we could have 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on. Okay, a term is a member of that sequence. So in this case, 1 is a term, 2 is a term, and so is 3. So we've got 3 separate terms to make one sequence, and our sequence is repeated over and over to make a pattern. Okay, now a linear sequence is where we have a number pattern where the number increases by a certain amount each time. Okay, we can also call this a common difference in terms of algebra. So, let's have an example, shall we? Okay, if you want, the whole purpose of this is to make some kind of a rule. Okay, so we make a general rule so that we can make predictions later on. This is one of the key things with algebra, is that we observe the world around us and we try and connect the sequences to make a pattern, and then from that pattern we make a general rule, and then from that rule we try and make predictions, or we try and work backwards to solve some kind of problem. However, that's a bit much to be covering right now, so let's do it step by step so that later on we can do that kind of thing. So, here we have a pattern. It is 3, 6, 9, 12. Step 1, in trying to find our general rule for this. Let's break it down. Let's make a table. So, our first number, 1, first number or position number, is 3. Our next number is 6. Our next number is 9. And then after that, it's 12. Okay. That's our first step. We've filled in our table as much as we can do. I'm pretty sure that a lot of you have already found the pattern here, but for those of you who haven't, let's just keep going, shall we? So, what is our common difference? How much has it changed by between each of these numbers? Let's fill in another part of this table, shall we? So if I'll just rule in a line here and try and write smaller. We've got from 3 to 6, there's a difference of 3. From 6 to 9, there is a difference of 3. From 9 to 12, there is a difference of 3. Okay, this is definitely a linear pattern because there is a common difference where each time we are increasing by 3. So, where to from here from making our general rule? We've got, if you can't find the general rule straight away, that's okay. We've got another step we can do. So, if it's going to increase each time, let's see what happens when we multiply it by the difference, shall we? So, 1 times 3 is 3. 2 times 3, which is our difference. Let's write that in here. Difference. 2 3s are 6. 3 3s are 9. 4 3s are 12. Okay, I think and it matches each time. So let me just color code this. So we've got our differences. We've got our actual terms. Each time we multiply by 3, we get our actual terms. So 9 matches up with 9, 12 matches up with 12. So that would mean if we're using the letters that they give us, t would have to equal our difference, which is 3 times n, and you don't have to add or subtract anything, and that is our rule. So we can use this rule to tell us what 5 is going to be. 3, so our term number in this box here is going to equal 3 times 5. 3 5s are 15. Now, did that go up by 3 from 12? 12 plus 3 is 15? Yes, it did. Okay. Let's try something harder, shall we? Okay. So, here we have got, whoops. Here we have got 6, 11, 16, and it continues on. So, step 1, fill in our table. We've already got position numbers up here, which is great. So let's just continue it on. The first one is 6. The second one is 11. The next one is 16. And we don't know the rest yet. Alright, step 2. Let's work out the difference. It has gone up or down? Yep, from 6 to 11, it's increased by 5. From 11 to 16, it's increased by 5. Cool. That was easy. Difference. Excuse me, I wrote 15 instead of 5. Okay. So, let's find out what our difference times our position is. And just using this letter up here, I'm not adding anything extra. Just using everything that we're given here. So, 1 times 5 is 5. 2 times 5 is 10. Now, don't worry if it doesn't match your term straight away, okay? We're just building something to try and make a pattern here, okay? So just keep going as much as you can. So, 3 times 5 is 15. Cool. So it increases by 5 each time. We can see our pattern. It's 5, 10, 15 with something else added. Okay. Now, let's look for our second difference, shall we? So here we've got 6, here we've got 5. What's the difference? 1. Here we've got 10, but the term is actually 11. What's the difference? 1. Okay, let's try the next term. The next term is actually 16. What have we got? We've got 15. What's the difference between them? 1. Are you seeing a pattern here? So each time we are multiplying by 5 and adding 1. So 6 is the same as our position 1. 1 times 5 is 5 plus 1 is 6. 2, try the second. 2 times 5 is 10 plus 1 is equal to 11. 3 times 5 is 15 plus 1 is equal to 6. Okay. So here we've got the difference is 5, 5n, 5n. Let's put that in brackets. So that's part of our rule. And then here we're adding 1 each time. So 5n plus 1. And that will be our part of our general rule. But what equals 5n plus 1? Our term. Okay? So if you look here in our table, I've just circled term, which is t. So our general rule is t equals 5n plus 1. Okay? So in this part, we're just focusing on making our rule, and later on we'll work out how to use it. Cool. Let's do another example, shall we? Oops. Let's see if I can help you see that. Okay. We've got 12, 10, 8, 6. What's step number 1? That's right. Step number 1 is fill in this table. Position 1, our first number, 12. 10, 8, 6. What's our difference? Step 2 is finding the difference. Okay, it goes from 12 to 10. Is that going big to bigger numbers, or is that going to smaller numbers? Yep, going to smaller numbers. So we're going to have a negative. So here our difference is negative 2. From 10 to 8, negative 2. 8 to 6, negative 2. Okay. Still can't see that rule yet, can we? But we can see that we're going somewhere. So step 2. That was 1, 2, 3. We're step 3. Step 3 is we multiply the difference by our term number to see what's happening. So in this case, it's negative 2 times n. So negative 2 times 1 is negative 2. Negative 2 times negative 2 times 2 is negative 4. 3 times negative 2 is negative 6. 4 times negative 2 is negative 8. Don't drop those negatives because that's something that I tend to do and that is not correct. So, well, it's definitely making a kind of a pattern. It looks nothing like the previous examples, does it? But that's okay. We've still got another step we can do. What is the difference between our latest numbers and the actual terms? Right. Negative 2 plus what equals 12? 14. Negative 4 plus what equals 10? 14. Oh, this isn't looking so scary after all. Negative 6 plus what equals 18? 14. Sorry, negative 6 plus what equals 8? It's 14. Negative 8 plus what equals 6? It's 14 again. Cool. So we are adding, so in here we are adding 14. Okay. So now we can put these two together. So we've got negative 2 times n plus 14. But what does this equal? This equals the value of our term. So we put equals to t. And this is our general equation. Okay. So let's use this rule to work out what our fifth position term will be. What's the value of our fifth term? So let's look at this. If n is equal to 5, we just replace or substitute the n for a 5. So if we were going to do that, we would be going t is equal to negative 2 times 5 plus 14. Negative 2 times 5 is 10. Sorry, negative 10 plus 15. 14, sorry. It's going to be 4. Okay. And we'll do more on using these equations in another video. Thanks for watching. Bye for now.